It is Monday, February 6th. Today we talk about the generalized hough transform, which we could just refer to as GHT. GHT is the generalized hough transform. It generalizes the ways to detect the lines. It is general in the sense that you don't have to use. Why did my lights turn red? Anyways, it generalizes the way that the shape can be detected. So previously we were able to only detect lines because we have a equation, we have a mathematical expression to express the shape of a line, which is just a straight line. We also have mathematical ways of expressing circles and as well as other shapes. The great thing about the generalized form is that you don't need a mathematical line, a mathematical expression. You can simply build it through an R table, and based on the R table, the machine will search for that shape that you're looking for. So to illustrate an example here, on the blackboard I have drawn a blob, and this blob is a random shape. And what we do is we record the shape of this blob into an R table. And this R table will tell us what the shape looks like, and based on this R table, we'll find this blob in the image. So there are a couple things that you need to know. At any given point x, y along the edge of this blob, we have we find a reference point. In this case is the centroid of the blob, and in the centroid of the blob, what we do is we find the radius, and within this radius we try to find the alpha of this radius. So in this case, the R is a vector, and this vector records the angle and the magnitude of this vector. So how long this row is and the angle that is turning. So once we get that, we'll record it in the R table. So in this case, this looks like 135 degrees. So we would go to for 135 degrees, this line, theta. So this line is the line that represents the edges. The best represents the gradient information of the edge. So this is the gradient of this pixel. And we go here, we find the gradient of this pixel. In this case, it looks like something like 80 degrees. And inside 80 degrees, we record the number of vectors that have this gradient. So we will do this for every single pixel on this edge. Then we will be able to get this R table. So once we get this R table, we run this R table through our sample image, and we try to find pixels that have all vote to this reference point. If we have an image where all the edges vote to the same reference point, then we know that this shape is there, and we have officially recognized that shape. If it does not vote to this reference point, then we know that's not the image we're looking for. So that's a generalized idea of how we're going to do this. I think in the next example we'll talk about rotation invariant, and we'll see an example of how this generalized hough transform works.